Okay, so section 2.1 functions, we're skipping right into chapter 2. We are going to, I believe, blow right past chapter 3 and not do it at all. So we're going to skip around and not do everything, just so you're aware. It is impossible to do that entire textbook. Just ain't going to happen. Okay. So today we're going to start out talking about interval notation. An interval notation is just another way of stating an interval of two numbers. Not everything is a particular value. It's not always x equals 3, x equals 5, x equals negative 9. It's not always a particular value. Your answers aren't always that. Sometimes your answers are a range of values. Okay, x is between 3 and 10. It's a range. Everything can work between these two values. Sometimes that's what you get. It's whether or not it makes it a true statement. Inequalities are that way. Inequalities are almost always a range of answers. Your domain and range are given as a range of answers. Things along those lines are given as given as a range rather than a particular individual value. Interval notation is just a different way of stating it. Rather than using inequalities, we can use intervals instead, and it's done kind of the same way. So there are two kinds of intervals that you deal with. You deal with open ones, where the end point is not part of the answer. Then you have what's called an open interval, because it goes right up next to it. It's like having on a number line, we have a number line answer. You have the open circle. The number at that open circle is not included, right? But we go right up to it, so we put a circle on that number, even though like we have an open circle on 2. 2 is not part of the answer, but right up close to it is. That would be an open interval. So we would have a parentheses either end. Okay. A closed interval, the endpoint is included. That would be an or equal to. That would be the equivalent of a solid point when you're doing an inequality on the number line. Okay, so if the answer is part of the answer, if the number is included as part of the possibility, it's a bracket. That means the number is included in my interval. If it's not, if it's an open interval, that means the number I'm talking about is not included, but we're going right up to it. Okay. Everything that can be written as an interval notation can also be written as inequality notation. Okay, so the first one we have here, the first example, we have x is between C and D, inclusive. X is greater than or equal to C, less than or equal to D. That means C and D are included. That would be a closed interval. Closed interval from C to D. That means C and D are included in every number in between C and D. So that would be a closed interval. C and D are included in everything in between them. Next one I have, x is greater than or equal to C, but less than D. So this one is a half open or half closed. You can call it either way. C is closed, but D is open. C is included in my answer. D is not. Goes right up to D, but doesn't include D itself. Okay. This is interval notation. Use this a lot in calculus. We're going to use it in here. I'm going to use a lot of my answers this way. Your textbook is kind of iffy on this. But either way works. Either method works. This is the same thing. It's greater than C, less than or equal to D. This is, once again, a half open or half closed. You can say either way. Okay, because one side's open, one side's closed, so it's either half open or half closed. Either way you want to look at it is okay. You just have a complete interval. It's like the glass is always full. Half water, half air. It's full. Okay. Next one, x is between C and D, not including C and D because it's not or equal to. That's a completely open interval. Now, the next ones are where it starts to get a little tricky. X is greater than or equal to C. That means C is my smallest possible value. It includes C, So I got an open bracket on C is the smallest possible value, but how large can it get? It can go towards infinity. So my interval is from C to infinity. It includes C, but infinity is open. Infinity is open. Infinity is always open. Infinity and negative infinity are always open intervals because you can't actually be that value. Infinity is not a number. Infinity is a concept. So you cannot actually be the number infinity. There is no number. It is a concept. So if you're going towards infinity, that is an open interval because you cannot actually come up with an end value. Okay, so if it goes towards negative infinity or positive infinity, that would be an open interval. This one is the same idea. X is greater than C. So it's an open interval from C to infinity. X is less than or equal to D. This is from negative infinity to D because everything's smaller than D. So I want to go from everything smaller up to D, so it's open interval on negative infinity up to closed interval on D. So D is included in everything smaller than D. Everything smaller than D, D not included, X is less than D. That's an open interval from D to negative infinity to D. And they're both open. Again, infinity is always open. All real numbers. I love all real numbers. Everything works. All real numbers, everything's okay. Which means we go from where to where? Negative infinity to positive infinity, and it is an open interval. Negative infinity to positive infinity is all real numbers. Which is, if you handwrite it, it would be that. All reals. It's got the double line on there. Why the double line? Because that indicates you got the double line. It's all real numbers. Okay. Every group of numbers has something like that that stands for it. All real numbers. Z is actually the integers, I believe. It's been a while since I've done some of those groups. Okay. Questions on this? Interval notation is just a different way of writing an interval of numbers from here to here. That's all. Okay. So graph the interval on the number lines. So the idea is we can graph these just like we can any other interval. Open interval means that the point is not included. So on the number line, that would be an open circle. Bracket means it is included. So on a number line, that would be included. It'd be a closed circle. So for the first one, we would have from -2 to 9. With open circles on -2 and a closed circle on 9, and everywhere in between. Okay, does that make sense? Yeah. It's just getting yourself to a new point. Okay. For B, from negative infinity to 3, I only have one actual number I'm concerned with, so I'm only have one number on my number line, which would be 3. It would be open or closed on 3. Open, and everything smaller or larger? Smaller, because it goes to negative infinity. So it looks like that. And the next one, the interval from 2 to 5, is 2 included? Yeah, is 5 included? Yes. So, everything else. Okay? So it's not a big deal. This really shouldn't be hard. Next one, solving an interval notation, solving quadratics, and then stating the answer in interval notation. So I don't have an equal. So x isn't going to equal some number. It's going to be less than. So I have an inequality. So it's anytime you have an inequality, you're looking at a range of possibilities. How do you solve this? Well, first thing you do is you solve as if it were equal to 0. And what's the easiest way to solve quadratics? What's the easiest way? If you can do it, what's the easiest way? Factor. Yeah, you want to factor. If you can factor, you factor first. First and foremost, you want to factor. If you can't factor, then I skip completing the square. Go to the quadratic formula, but you have your graphing calculators. You can have your graphing calculators for you if you need to. But you should be able to do this one by hand. Two numbers that multiply to give me positive 3 that add to give me negative 4. Okay, x minus 3, x minus 1 is equal to 0. So what are my values of x? 3 and 1. And those are my solutions for equals. It does not give me my range. Now, to find the range, it's actually really kind of cool. I like to set up a sign chart for this one. 1, 3, those are my possibilities. And what you do is you pick a number smaller than 1, and you test it. And you see if you're going to get something that's going to work or not. It's going to make it true or false. So any number that's smaller than 1, I can plug in there. Any number that's smaller than 1, I can plug in there. What is the easiest number smaller than 1 to plug in? 0. 0 is, by God, it's the easiest number to put in, period. If I put in 0, what do I get? I get 3. 0, 0, 3. Is 3 less than 0? No, so it doesn't work here. That's false. It doesn't work on this one. Okay. So I pick a number between 1 and 3. Any number between 1 and 3. I cannot use 1. I cannot use 3. What is the easiest number between 1 and 3? 2. And that's because it's the only whole number between 1 and 3. That's why I'm going to pick 2. So I plug 2 in. 2 squared is 4. 2 times 4 is 8. So I have 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. Is negative 1 less than 0? Yeah, so that's true. And then I pick a number larger than 3. A million! A million squared minus 4 times a million. And no, a million squared is not 10 million. It's a 1 followed by, not by 18 zeros. Okay, minus 4 times that, that's positive, right? Plus 3, that's positive, so this is all positive. A positive number is not less than 0, so I know it's false. I don't need to know the actual number, I just need to know it's going to be bigger. And I've done that. When I do calculus, I do sign charts for some of the stuff in calculus. I just pick a number. It can be any number. Okay, 10 billion. If I put 10 billion in here, is it going to be positive or negative? Okay, it's going to be positive, which just makes it greater than which makes it greater than 0, not less than 0. It doesn't work. I don't need the exact value. I'm just going to figure out whether or not it's going to work or not. Okay. If you want to plug in a specific value and test it, feel free, knock yourself out. But use a mental exercise. It's fine. So where's my range? Between 1 and 3. So in interval notation, I have 1 to 3. Is 1 or 3 included?
No.
No, because it's less than. It's not or equal to. If I put 1 in here, I get 3. If I put 3 in here, I get 3. 3 is not less than that. So 1 and 3 are not included. So that's the open interval from 1 to 3. Okay. How would I write this in inequality notation? Like that. Now, but what did the question ask for? It says solve in interval notation. So this is the correct answer. This is not the correct answer. Because what did the question ask for? The question wanted me to do it like this. They are the same. They are equivalent. However, what was asked for? You do have to be careful about reading questions. We good so far? Okay, next. Yeah, I am recording. Okay. The domain. This is probably one of the more important things. This is also one of the ones we use interval notation on an awful lot. Domain of a function. Okay. The domain of a function is all the reals such that the machine produces a real output. In other words, what numbers can you put in and what numbers can you get out? So what can I put into my equation? What can I get out of my equation? What values do I have that I'm allowed to have? Okay, what will work, what won't work? We have a couple of restrictions. Okay. Thou shall not divide by 0. We're never allowed to have 0 in our denominator. And no even root of a negative. So it's a square root or fourth root or sixth root or eighth root or some other even root. You cannot have a negative inside. We're talking in the real numbers here, not complex numbers. We're not dealing with the complex values, only real values. You cannot take the square root of the negative. These are your most common restrictions on domain and range. There are other restrictions. They tend to be specific to particular types of problems. Trig functions are ones that come to mind almost immediately. The range of the sign is between 1 and -1. You're never going to just take the sign of an angle and get a number larger than 1 or a number smaller than -1. Your function can be that if you move it up or down, but generally speaking, the range for sign is between -1 and 1. Okay? Your domain is everything, but your range is limited. We'll get more into that as we get to it. Okay? Some things are limited, some things are not. And what we're dealing with here is, the things we're concerned with is what makes our denominators 0, what makes our numerator, or what makes our function, our square roots negative. So I look at the first function. F of x is x squared minus 6x over x minus 1. So I'm looking only at domain. All I'm caring about is my input. What am I allowed to have is sometimes easier to answer by saying, what am I allowed not to have? So in the first function, f of x, x squared minus 6 over x minus 1, what am I not allowed to have? 1. X cannot be 1. That's sometimes much easier to find what something can't be than what something can be, and then come up with your interval based upon that. So this first one here, x cannot be 1. 1 gives me 0 in my denominator. Anything else, I don't care. I just can't have 0 in my denominator in this problem. Any other number will not give me 0 in my denominator. I don't care what happens in my numerator on this problem, on this one. Now, so that's not interval notation. How to do interval notation for this? So is 1 included? No. So I'm going to have open on 1. Can I have numbers smaller than 1? How small can I go? Anything smaller than 1. So I'm going to go from -infinity to 1, and that's open. Because I can't be 1 in -infinity. It can't be that. So are those my only possibilities? No. What else can I have? Everything larger than 1. So I can also have the open interval from 1 to positive infinity. And I'm going to have the union of those two. Because both of those will work. And the union is anything that works in one and anything that works in the other.
Do you have to?
Yes, yeah. So it's the union of the two. As opposed to intersection. Okay, a union is everything that's in this and everything that's in that. Everything that's there is good. Intersection, which is the upside down U, is just where they cross. And we won't have intersections. We're going to have unions. Okay. So look at the next one. So I have my restrictions on the next one. Once again, it's often easier to figure out what x cannot be than what x can be. So, the square root of f plus 2. F cannot be -2. Well, actually, can f be -2?
Oh, yeah.
Because I can take the square root of 0. What's the square root of 0? 0. There you go. It cannot be less than -2. Anything smaller than -2. So f has to be greater than or equal to negative 2. So once again, I want to put this in interval notation. So what's the smallest value f can be? Negative 2. Open or closed? Closed, because it can be negative 2. Closed interval on the negative 2. And how big can it be? Infinity and beyond. Well, it is entirely possible to go beyond infinity, because not all infinite groups are the same size. Okay. So, next one. Take a minute, figure out the restrictions on the next one. What are we not allowed to have? What are we allowed to have? This is a complicated one because you do have to include both the numerator and the denominator. Okay. So let's take a look at this. We do have to concern ourselves with the numerator in this particular problem only because the numerator includes the square root. We didn't in the first one here because it didn't include anything we had to worry about. We didn't have any denominators, we didn't have any roots, we didn't have anything we concern ourselves with in the first one. A polynomial, everything is fine in a polynomial. The numerator in the last problem is not a polynomial. I do have to be concerned with this. So my restriction to my numerator is k needs to be greater than or equal to 2. Any number smaller than 2 is going to give me a negative square root. That's no good. Irregardless of what's going on in the denominator, I cannot have anything smaller than 2 in my numerator. Now, if I look at my denominator, what are my restrictions there? Ignoring the numerator and ignoring the restrictions I already have, what are my restrictions for my denominator? And it cannot be plus or minus 3. K cannot be 3 or negative 3. Now I need to combine those restrictions together. So the first one is actually more restricted than the bottom one, right? Everything needs to be larger than 2. Negative 3 is smaller than 2, so that doesn't bother me. The denominator can't be negative 3, but I can't be negative 3 anyway, so I don't really care. Does that make sense? I can't be it because the top one's actually more restrictive. So I don't have to worry about negative 3. That's already taken care of. Now, 3, however, is an issue because 3 is larger than 2. I can't have it be 3. I can have it be everything larger than 2 except for 3. So in interval notation, I go from 2 to 3, half open or half closed, either way you want to look at it. 2 included, 3 not included. And then the union from 3 to infinity. So I can have I've covered all my restrictions. There is nothing in there that I cannot have in my problem. So if I pick any number between 2 and 3, I'm good. If I pick any number larger than 3, I'm good because it doesn't worry about any of my restrictions that I came up with. Once again, it's often much easier to figure out what something can't be than what it can be. Yes?
Okay, how do you get the negative 3 and 50?
Because I can still keep going larger than 2. Anything larger than 2 is good, except for 3. So what this does, this gives me everything from 2 to infinity, except for 3. So I have one group goes from 2 to 3, one group goes from 3 to infinity. 3 is not included in either one of these. So it's this group and this group together. This tells me everything from 2 to infinity, except for 3. Okay? Does that make sense? No. Infinity is always open because can we actually count to infinity? No. You can't actually get to that number. Infinity is always open. Never closed on infinity. Okay, the difference quotient. By the way, calculus preview. This is the difference quotient. This is something that is used to define many of the things that you'll be doing in calculus. So this is a good preview of an important part of calculus. Okay. So computing the difference quotient. So the difference quotient is f of x plus h minus f of x all over h. So you want to put it in there, compute it, and simplify. So, should I do the easy one or the hard one?
Easy one, but the hard one.
Should I do the easy one or the hard one?
Oh, you do the hard one.
All right, I'll do the hard one. Then I'll let you do the easy one. So I'm actually going to do the x to the fourth first, rather than the x squared, rather than the 4x minus 1, because that's going to be nasty. Okay. All right. I'm trying to see if I can guess this using my calculus skills first, rather than actually have to take x to the fourth and expand it out. Because here's what this one is. It's you're doing this. So what I'm taking is x plus h to the fourth minus x to the fourth all over h. That's the difference quotient. So I have to take x plus h to the fourth power and then simplify that. Now, I'm not a big fan of this, but this is the one time I want to use it.
Oh, I remember this chart.
So 0 power, first power, second power, third power, fourth power. This is the row I want to have. Using the Pascal's triangle for binomial expansion, because that's what I have here. So actually, I like this. I kind of wish I was doing it on the screen, but I don't have enough room to really do it on the screen easily, so I'm going to do it over here. So here's what you do. What do? These are your coefficients, right? And then you have your x powers in descending order. X to the fourth, x cubed, x squared, x to the first. And then I go the other direction with h, because it's the other half of the binomial is h to the fourth, h cubed, h squared, h to the first. So coefficient x's and h's. So when I expand this out, I get x to the fourth plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the fourth all over h, and I still have my minus x to the fourth. Yes, ma'am. Question. I'm doing this one here. I'm doing the hard one.
Wait. Like, do you have to know this, or is it just?
No. I'm not going to give you anything that's nasty on the test.
Oh, I see.
So we don't do that.
Yeah. What? Yeah, and you can if you want to, or you can FOIL it out. I don't care. Either way, it's just this is one of the few times that the binomial expansion rule actually works well. It works in my favor. Now, I am not done simplifying by any stretch of the imagination. All I've done is simplify my functions. I'm not done yet. First thing is, I have x to the fourth and negative x to the fourth. Those go away. I can simplify it even more. What does all the rest of the terms have? An h, and the numerator does as well. So this h goes, and all the other h's reduce in power by 1. So my final answer on this one is 4x cubed plus 6x squared h plus 4x 4, that's a lousy 4. 4xh squared plus h cubed. Okay? Yeah, I did the nasty one for you. You're welcome. What?
How do you get the x plus h to the fourth minus x? Where did that come from? It's the very first thing you just.
Oh, because that's what this is. That's what this is. F of x plus h. F of x is h to the fourth, so when I take f of x plus h, what do? I take x plus h to the fourth. Right?
Yeah.
Function notation. We need to know function notation. Question? Yes. Because right here, this is what the difference question is. This is what I'm finding. F of x plus h, what is f of x? It's x to the fourth. So I take this to the fourth power, I take that to the fourth power over that. So in this one, what are you going to do here? Negative 4 x times x plus h minus, and then plus 1. That's just this part. And then on this one, I have the same thing over again, all over h. So that's what you're going to do. Remember, function notation. I take x, replace it with what? I replace it with x plus h. I take x, replace it with x plus h. That's function notation. Whatever's in here, I stick in here. That's function notation. You should know function notation by now. Whatever f of x is defined as something, if I change that to f of something else, I take x, replace it with that something else. Which is what I did here. I did do it on this one.
No, because why would you just plug in the x to the fourth and the spaced out?
Yeah, like what is like why would you like
Okay.
do the exponent on the h too?
Because I'm taking x, whatever, okay.
What is it?
Function notation. F of x is defined as x to the fourth. So whatever x is, whatever I'm taking my function of, I'm doing that to the fourth power. Whatever I stick in here. So what would f of k be? That would be k to the fourth power. Because I'm taking whatever this is to the fourth power. That's what f as a function is defined as. If I have f of 3, that means I have 3 to the fourth power. It doesn't matter what's in the parentheses. I take that entire thing to the fourth power. Not just x to the fourth and then add h.
What if you have x to the fourth and then say they put like a plus 2 out there?
Okay, so if I had a plus 2 here,
Yeah.
then I would have plus 2 and I would have plus 2. And then I would have plus 2 outside of the parentheses because what's being raised to the fourth power? Just the x object. And then I add 2 to it.
Yeah.
I'm replacing x, and whatever I do to x, I have to do to x plus h.
Okay.
Your turn, do that one. Let's do this in the interest of time. So it's f of x plus h, which is negative 4 times x plus h plus 1. That's f of x plus h minus f of x all over h. Plug in x plus h for x. Everything else stays the same. And then you have it repeated again, and it's minus in between. Now, let's simplify the numerator. So distribute the negative 4. Negative 4x minus 4h plus 1. Distribute the negative here. Plus 4x minus 1 all over h. The negative 4x and the positive 4x cancel. The 1 and the 1 cancel. And I have negative 4h over h, which is negative 4. Nice thing about when you do this, a lot of stuff does disappear right in the first step. All constants go away on your first step. A lot of other stuff goes away on your first step. Okay. I cannot stress enough that when you're doing your work, you need to be clear, meticulous, don't skip steps, write neat, give yourself room to work. I know in the notes there isn't always a lot of room to work, but when you're doing your homework and stuff, give yourself room to do the work. Be neat. Your first step has to be everything. Do not skip steps right off the bat. Notice when I did this, I put that down. I did not skip any steps. Could I have skipped steps? Yeah. I have the knowledge and ability to go straight from this first thing down to here. Not a problem. I would not recommend that for anybody. Okay? Don't skip steps. Show your work and be meticulous. It's okay to have more steps than I have rather than fewer. I'm okay with that. If it takes more steps to get it correctly, but you need to be clear and concise and show your work. I cannot stress that enough because things are starting to get complicated. In this class, things will be complicated, and you just need to be meticulous in your work. If you're meticulous in your work, you're more than likely going to do well. Okay, that'll make a big difference for you.